Disclaimer. This video tutorial is for training and information purposes only. The techniques and recommendations presented in this video are based on general best practices and experience. Please note that individual circumstances, such as specific company policies or industry-specific requirements, cannot be addressed in detail. The information contained in the video is not a guarantee of success in the subject matter and does not replace the need for individual preparation and practice. The content reflects the opinions and experience of the creator and makes no claim to completeness or accuracy in all situations. The creator accepts no liability for any direct or indirect loss, damage or inconvenience that may arise from the application of the content presented in the video. For detailed advice or special requests, please contact us at contact@experts4excellence.com. All content shown in this video is protected by copyright. Any reproduction or distribution is only permitted with our written authorization. Welcome to the course Basics of Lean Management. This is part 2 of the module and covers the basic concepts. It contains short breaks for your reflection and relaxation. Now, have fun with the basics of lean management. Let's now move on to the basics of lean management. You have probably heard the terms Kanban, just in time, just in sequence, and milk run and supermarket respectively. These are all elements of lean management. The method was developed between 1948 and 1975 by Kiichiro Toyota and his chief engineer Taichi Ono at Toyota in Japan. Therefore, the system is also called the Toyota Production System or TPS. Based on the main principles just-in-time and Heijunka, automation. It supports the goals: increase in productivity, quality and delivery reliability, job satisfaction, job security and fair treatment of employees, flexibility, cost reduction, sustainability. It has received international recognition through the Porsche crisis in 1990. The Toyota production system is usually presented as a so-called TPS house. It consists of the two pillars just-in-time and Heijunka, as well as the foundation resulting from Heijunka, Kaizen and standardization. The roof of the house is formed by the objectives of the method. These are the reduction of lead time, the reduction of costs and the increase of quality. All of this with the goal of improving the customer experience. In all activities in lean management, the focus is on people. Let's look at Kanban first. Kanban is the Japanese word for card, board or sign. It is the main principle of the just-in-time production. It enables pull processes. And it reduces stocks and work in progress in production. It is a demand-driven process control. It manifests the customer-supplier principle, SIPOC. It is very broadly applicable: products, software, services. It is conserving resources. There are different variants such as production Kanban, transport Kanban, purchasing Kanban, running card Kanban, stock Kanban, special Kanban. Let us first consider the classic production Kanban. Let's imagine a simple production consisting of two serially linked process steps, process step A and process step B. Let's further imagine that the process step B needs 3 parts from the process step A to work. It sends a request through a so-called Kanban card. On the Kanban card, all substantial information is noted. Then the process step A produces 3 parts and sends them to the process step B. If the process step B needs new parts later, it will send a new card to the process step A again. On the Kanban card, all important information is noted: the part number, a part description, the required quantity, the replenishment time, the order date, and the date on which the goods must arrive. And of course, the supplier of the parts. Nowadays, however, all Kanban cards can be processed electronically, i.e. they have a barcode so that they can be scanned by scanners and processed by computers. Let us now consider the basic principle of a Kanban with a first-in first-out buffer. Again, we consider our 2 process steps A and B. But now we install a buffer between the 2 process steps, the so-called first-in first-out buffer. Process step A produces parts and fills this buffer, while process step B removes parts from this buffer for further processing. So that the buffer does not run empty, however, a trigger point is set at a certain point, which triggers a Kanban card and sends it to process step A, thus initiating the replenishment process. In modern production environments, however, this all functions fully electronically as so-called e-Kanban within a manufacturing execution system. Process step A now starts to produce according to the information on the Kanban card and fills up the buffer again. We have now achieved the following: a pull process, a continuous flow, minimization on inventories. But how do we dimension the buffer and where do we set the trigger point? There are many, sometimes very complex ways of calculation. They are all dependent from the type of Kanban that is used. Usually a simple calculation is sufficient. A simple FIFO buffer Kanban is determined by the following parameters: SB, buffer size; SL, collective quantity, lot size; CD, daily consumption; TR, replenishment lead time, days, workdays; SS, security surcharge; PT, trigger point, release of Kanban card. The total size SB of the Kanban buffer is now calculated as follows: SB equals SL plus CDTR plus SS, and the trigger point PT as PT equals SB, CDTR. For the classic production Kanban, the calculation is a little bit more complex, as we now have to deal with transportation containers and multiple Kanban cards in the Kanban loop. The same parameters as in the previous calculation come into play here, plus QC, being the quantity of parts per container, and CA, being the amount of Kanban cards in the Kanban loop. This is the parameter we want to calculate, and here is the formula, how to calculate how many Kanban cards need to be in the loop. CA equals SL plus CDTR plus SS divided by QC. Now stop the playback of the video, lean back for a moment and think about where and how you could apply a Kanban principle at your home. Once you have found something, continue to play the video. Here are a few examples on how you apply a Kanban at home. The supply of milk and butter in your refrigerator. How could this be implemented? The number of remaining clean shirts or blouses in your closet controls when you should wash again. Now let's go back to our TPS house. We have now successfully covered the Kanban subject. Let's now concentrate on Heijunka. Heijunka stands for balanced production. It pursues the objective of having a balanced capacity distribution over all work steps in order to be able to realize a flow principle and cycle. This avoids congestion in the flow as well as unnecessary downtimes. Let's imagine we have a serial production of 5 different work cells. That can, for example, be milling, turning, or drilling machines. The horizontal line represents the production flow while the vertical axis represents the capacity of each work cell. As you can imagine, with a setup like this, the capacity across the work cells is uneven and therefore imbalanced. What would happen in a flow production between cells A and B and cells B and C? What would happen to cell D? You have probably guessed it. Between cell A and B the material would accumulate, because cell B has less capacity than cell A. The same thing would happen between cells B and C. Cell D, on the other hand, would have large waiting times for material from cell C. Both are effects that you do not want to have in an assembly line. It would therefore be ideal if all cells had exactly the same capacity. But unfortunately, this is almost never possible in reality. Because then you could introduce an exact production takt. This means that each workstation needs exactly the same amount of time as the previous and the following one to process its parts. The parts could move on in a clocked manner. That would be a desirable condition. But with the Heijunka approach, a pragmatic solution can be created here. The production line is designed so that each subsequent production step has a little more capacity than the previous one. Naturally, the first production step has the lowest capacity and the last step has the highest capacity. The step with the lowest production capacity is called bottleneck. This determines the takt. This is not always technically easy to realize, but should always be strived for in any case. Sometimes a redesign of the product can also have a supporting effect. With such an implementation you get a pull effect quite automatically. Each subsequent workstation pulls the product from the previous one as soon as the processing is completed. This is exactly what you want in lean production, because pull creates flow. With Kanban, tact, pull and flow we have realized the essential elements of just-in-time production. Now, that we have created just-in-time by implementing tact, pull and flow we can realize the so-called single-piece flow or batch size 1. This allows us to exactly produce what the customer has ordered in exactly that sequence the customers have ordered. It significantly reduces production stocks and throughput times. And the production starts only when the customer places an order. The customer can be an external or an internal customer. Lean is considering everything as a customer-supplier relationship. These are key elements of lean manufacturing. Let's do a quick check, what we have covered from our TPS house so far. We have covered Kanban, Heijunka and flow. The remaining element of the 7 watts elimination will be covered in the next module. But before we go there, let's first have a quick check on a special, very sophisticated form of just-in-time, which is just-in-sequence. The objective is material, individual parts, etc. are fed to the workstations in exactly the right sequence, so that the finished products are produced exactly in the sequence in which they correspond to the customer's orders. Example: Porsche Leipzig, the models Panamera, Panamera Sport Turismo and Macan are manufactured on the same line, in the exact sequence of the incoming orders. One very important element of just-in-time is having versatile qualified people. The objective is continuous further qualification of employees, ideally accompanied by an increase in salary. This increases job satisfaction and thus the level of performance. Employees are more flexible, which increases flexibility, especially in high-mix productions. If you run different workstations or machines and your people are only trained on one workstation or machine, your operations will end up being very inflexible and vulnerable. If some people call in sick, you may have a problem running the process step of that person. Therefore, it is overly important to train your people on various process steps or machines, in order to stay flexible. In addition, it increases job satisfaction and employee liability. With that, we have successfully completed the second chapter in this module. Please take a moment and think about what your 3 key learnings were in this chapter. Write them down. Ask yourself if you can use these lessons learned in your daily work. And if so, how? Now reward yourself and take a short break.